This is the pinwheel tiling. It's aperiodic, meaning it's a non-repeating pattern. This is why I wrote a shader that displays its infinity. And I'll show you how I made this. This triangle tile can be divided into its copies 5 times. And those copies into 5 more, so on and so forth, looking like a fractal. But I'll stop at 1 magnitude. In order to find where them triangles are, we need to start from the base triangle. Quick explanation on the way computers process shaders. Computer gives coordinates and shader says what color it is. That's basically it. Therefore, we need to find in which triangle does this dot belong to. We need to get the bigger triangle this base triangle is in. Unomas. Now we want the point to be scaled down until it's inside the base triangle. Easier question. Get point from base triangle, then scale it up. This +1 line is rotated by arctangents of half and is bigger by square root 5. These numbers will be very important. This spiral. How do I create a function that finds them dots? Start with simple getPrevious to getNext function. The n equals 0 will be coordinates 0, 0. N equals 1 will be 1, 0. For n equals 2, take previous length, multiply by square root 5, rotate by minus arctangents 1 over 2. Add it to previous points, and there it is. Yes, coordinates being whole numbers is not a coincidence. Using all that, we write a formula that looks like this. Notice this rotate function just shoved in this equation. This will cause mathmaniacs to break my kneecaps. Let's rewrite this. I'm using complex numbers, by the way. See this natural log of root 5? When it gets exponentiated by e, result will be root 5, which is what we need. Voila! It works! But it's not good enough. I need to get rid of iteration. Need to find summation up to n. Now just substitute it and... wow. Let's see this bad boy in action. If you plug in minus infinity, or just a big negative number, you'll get minus 0.5, minus 0.5i coordinates. That is the true center. Heads up, at this point in the video, I've decided to follow how my code is drawing triangles. And it's all mirrored around y-axis. So... do you notice the pattern around this center? Let's inscribe circle 0 with radius between these points. Subsequent circles will have radius of previous circle multiplied by square root 5. Let's pick a random point. We want to scale down and rotate it around center, so it's between circle 0 and circle 1. We find distance d between point and center, and angle alpha. Angle alpha is fine as it is. Distance d needs to be logged in base square root 5. Also needs to be fixed with a log of square root 2 over 2 of same base. Because our circle zeros is radius, it's square root 2 over 2. I'll call this new number dl. dl has two important parts, its whole number and its remainder. dlw for whole number and dlf for remainder, or fraction. That's the function. Using dlf, we can get a new distance d such that it will be inside circle 1 by exponentiating it with power of root 5. And our new distance d will be in range from 1 to square root 5. Using dlw, we'll get new angle alpha by multiplying with arctangent's half and subtracting from alpha. Let's see this in action. And if the point is inside circle 1, it will not be scaled up or rotated, because it's already inside. With this, we've constrained infinity. We've put infinity into a chokehold. Domain reduction or something. I didn't watch Jujutsu Kaisen. Now with the meticulous part. Inside the circle 1, we have to manually find these lines. Now every part of the circle 1 is inside a triangle. Let's take a look at coordinates taken directly from my code. If you look closely, you will notice that coordinates make no sense. The x-axis is rotated by minus pi over 4, and the y-axis is flipped. This is because I found those coordinates based on vibes. Maybe I'll fix my code in the future. Maybe I'll fix manim? This is what coordinates would look like if I was a sane person. I know radius of circle 0 is square root 2, but that's negligible. Next up, random point. Take its triangle. Then convert point into barycentric coordinate system. Coordinates of point T will be relative to A, B, and C. One for each triangle points. Point T's first coordinate number corresponds to how close it is to point A. Second corresponds to B, third to C. To convert from classic Cartesian to barycentric coordinate system, take area from points BCT divide by area ABC. You will get first coordinates out of 3. For our point T, area of CAT divided by area of ABC, you get second. Area of ABT divided by area of ABC, you get third. To convert from barycentric to Cartesian coordinate system, multiply first coordinate T by point A in Cartesian coordinate, second coordinate T by B, third coordinate T by C. Sum them up, you get T in Cartesian coordinates. Okay, so division by area is not completely correct when point T is outside triangle. Area ACT needs to be negative in this case. Therefore, just use this formula found online. Also, sum of all barycentric coordinates will always be 1. And triangle can have any wild shape. So I apply barycentric coordinates here to get one of 5 triangles. Get those barycentric coordinates and normalize points. Recursion achieved. Let's apply our coloring in here. These parts outside of our circle is not actually used, but every piece inside circle is necessary. Even this one. Put it all into code, then we get this. All we gotta do is get triangles recursively about circles' magnitude amounts. or DLW for short. And there it is. Beautiful. Magnifique. We did it, guys. Just wish you helped a little bit and not just let me do all the work. Interesting thing I found about pinwheel tiles. Every triangle can be described by a single base 5 number as a coordinate. First, let's name these subtriangles with letters. Note that these assignments are arbitrary and you can assign them whatever symbols you prefer. This one is coordinate A, this one is AA, this one is AAA. Can you figure out this one? Pause right now. It's AEE. Try figure on this one. Pause right now. It's ADD. This is not a special property of pinwheel tilings. It can be done with simple squares. I've been wanting to add seamless texture into this. It would be a perfect way to create non-noticeable and repeating texture to specifically avoid this. Oh, I could definitely be peer pressured to write shaders for those two single-piece aperiodic tilings. And, never made explainer video or successfully taught someone. So if I suck, tell me in the comments. Code is in description below, check it out. So long, Mathemaniacs.